A couple of things, guys, about branch circuits that we're going to go. Um, what we did in the past, Adam, we did branch circuit for residential. When it comes to branch circuit, right, we guys did the branch circuit for dwellings and what's not, receptacle and lights. Branch circuit for a commercial building is going to be coming from a three-phase system. So just quick reminder that the system that we're having is going to be a three-phase system. And then your branch circuits will be, this is my neutral phase A, phase B, and phase C. And when it comes to the branch circuits, guys, here's a chunk of light here, another chunk of light, and a third chunk of light. Let's say this is 18 lights, 18 lights, 18 lights. And then I'll grab these. These will be in phase A, these will be in phase B, these will be in phase C. Can you guys see that? And then my neutral comes out here and feed this, and this, and this. Any comments, any questions, how we do circuiting, guys, in a three-phase system? Any comments, any questions? So that's why I want to go over this chapter. Here's my transformer, guys, coming, and you put your overcome protection device typically here, and here, and here. These are all have to be tied together. So this is my 20 amp circuit. So what you do is you have a 20 amp circuit tied together with an approved handle, and then you go and feed multiple circuits. These are lights. So that's typically what we do in a commercial building. You take one phase with a neutral, and you feed multiple lights. So you take a phase from this panel and a neutral, and you go feed 18 lights. Typically 18 or 20 amp circuits. I'll show you the calculation. So count 18 lights, throw them in one circuit with a neutral done. 18 lights, throw them in another circuit, and with a neutral done, and so forth. So you can see how many lights, and the voltage system that we're using here is a 208. This is a 208/120 volt system. 208/120 volt system. So each one of these will be burning at 120, right? From here to here, it will be burning at 120 volt, and from here to here, well, no, from here to here, will be burning at 120. Any comments, any questions how we power lights in a commercial building? It's exactly like residential, except we add a third leg. We have 3 legs. Any comments, any questions? When it comes to the industrial project next time, Karen, we're going to be using a voltage that's called 480/277. So we're going to take one phase and one neutral, give me 277, and burn all my lights at that voltage. Everybody understand how we do circuiting in a 3-phase system? Now, Adam, when you start laying out your receptacles and your lights later on, you're going to count 1, 2, 3, 4, 5, 18. Drop them on one circuit, 1 amp circuit. Cool? That's in terms of load. I'll show you how we do the calculation. Now, in terms of receptacles, guys, these are lights. Now, how about receptacles? I'm going to go just right here and draw the same. Here's my receptacle. Here's my receptacle. And throw a couple of receptacles. Okay, so give you an idea. And then we're going to go the same system that I've done here. We're going to feed receptacles from it. Ground, neutral. Here's phase A, neutral, phase B, and phase C. And I want to go directly to this set of receptacles, directly to this set of receptacles, directly to this set of receptacles. Don't forget that you have to go overcome protection device. These have to be tied together. So here's my 20 amp circuit. And then my neutral here will jump in here, feed this, and feed this. And these are my receptacles. You guys see that receptacles? Now, how many receptacles you can feed from a 20 amp circuit? 13 receptacles. So I have 13 here, 13 here, 13 here. 13 receptacles you can feed from a 120 amp circuit, Karen. Now, obviously, we don't want to load it. We don't want to load up to 13 receptacles. Write yourself a note when we start circuiting. Very, very important, guys. When we start circuiting up to 13, you can put one circuit. Now, we don't want to load it up to 13, right? Because especially in the commercial building. So what we typically do is we cut this by half. When you cut 13 by half, design-wise, not code-wise, what do you get? 6.5. You can't have 6.5. So we end up with doing 6 or 7 receptacles. So the criteria for sizing, guys, we're going to have 6 here, 6 here, and 6 here receptacles. In the commercial building that we have, when you start laying out your receptacles and you start circuiting them, you're going to tell me, Chad, how are we going to circuit these? We're going to put 18 lights in one circuit and 6 receptacles on one 20 amp circuit. Any comments, guys? Any questions about circuiting in a 3-phase? Circuiting, yes, sir.
What was how many quads were you putting on a circuit?
A quad is counted as 2. Well, yeah, 3 quads, so that will give you 4. Yep, 4. Yeah, absolutely. Yep. Because a quad, you guys on the project, good morning, Derek. On the project, they ask you about a quad. A quad obviously has 4 in it. There's 1, there's 2, and there's another one here. And so you can put 2 of these. Throw 2 of these on one circuit, because 2 times 2 give you 4. Actually, so 2 of these. That'll give you 4. If you throw another one, that'll give you 8. We'll be stretching it a little bit. Any comments, any questions about circuiting? So that's how we circuit in terms of receptacles. We can, but I want to remind you, you can go as high as 13 receptacles. But we don't want to do that. We'll cut them on a commercial building into 6 receptacles. In the office area, when you go office, pick up your receptacle, up to 6, circuit done. 6, circuit done, Even in the quad, the quad, guys, in the office, we're using them for office people, plugging a lot of stuff on them. So we're going to use 2 quads. And if you switch it to 3 quads because you ran out of, there's only 1 quad sitting there, it's not a big deal. But hover around 6. If you added a 7th receptacle in a circuit, not a big deal. Remember, what's your max? Max is 13, so you're still within the max. So don't sweat it too hard, but you don't want to be loading a 12 receptacle and 13 receptacle, the circuit. Any comments, guys? Any questions about this? So what we did, Derek, my friend, is we said in a commercial building, you have 2 at 120. You can have, this is how we circuit them, phase A, phase B, phase C, shared neutral, or not. You don't have to share neutral. And we put up to 18 lighting fixtures on a circuit. I'll show you the calculation later on when we do calc. And if you are using receptacles, if you're doing receptacles, this is important because you guys are going to be circuiting. You're going to ask me. You can put as high on a 20 amp circuit, as high as 13 receptacles on each leg. So 13 plus 13 plus 13 give you a bunch of receptacles on one circuit. This is a 3-phase circuit, sharing a neutral. But for design-wise, we like to hover over 6 receptacles in an office building. If it's an extra one, you put 7. Is it a big deal? Did you guys hear me? Not a big deal. Remember, what we shoot for is 6. What the maximum is 13. And try to find, when you're circuiting, if it makes more sense to add that tiny little receptacle sit there to make him 7. Don't sweat it too hard. Any comments? Any questions? Same thing. These are, guys, one circuit here. Can you guys see that? So this is a 4 wires, phase A, phase B, phase C, and a neutral. Any comments, any questions about circuiting? So important, guys, to understand how do we do circuiting in a 3-phase system. We take 3 odds with a neutral and pick receptacles and pick lights. Okay? So keep in mind, do you have to share the neutral? You don't. A lot of application, they tell you with the grid specification that we have, they tell you they don't want to share a neutral. So if you don't want to share a neutral, can you guys see that neutral that we shared here? So if you don't share a neutral, you just split the neutral right here, right? At the source and take 3 neutrals. Any comments, any questions? So this is probably the most important thing. This chapter, then that will relate directly to the chapter that we're doing, guys. Determine the number of branch circuits for each set of load. Apply the adjustment factors, continuous load for motors and what's not, correct rating for branch circuits. So that's what we're going to be talking. So I tried to start with a big picture for you. That's what we do. 13 receptacles maximum, 6 design, and 18 fixtures. That's what we're going to do. And let's see what this chapter is talking about. determine, and then now we know how to circuit in a commercial building. The wire for a branch circuit, we're going to be talking about the wire for a branch circuit. You guys know that. This is not new. THH10 if you're indoor, THHW if you're outdoor. So that's the type of the wire insulation that we do on the branch circuit. When it comes to the commercial building, Karen, we do not, and industrial, use less than a 20 amp branch circuits. We don't even use 15. 20 amp circuit is the minimum that you go. So you're going to see, guys, later on, there are three types of branch circuits. There's receptacle branch circuits, lighting branch circuits, and equipment branch circuits. So we'll go receptacles. I told you how many, 6 for design. Lighting, how many? 18 for design on every one leg. And equipments, typically we send for equipment, guys, we send a branch circuit for every equipment. For example, you have a plotter right there. We need a receptacle dedicated for this plotter. What do? You shoot it a 20 amp circuit, a hot and a neutral to feed the receptacles. Karen, any questions? Any comments? Any questions? This is so important when you start laying out your receptacle, guys. How do you lay out your receptacles in the building? So that's what we're going to do. When you do conductors, let's start with the big picture. And then the big picture is you take your 20 amp circuit right in here, and you take a number 12 THHN, and you take Mr. and neutral with it, and that's your branch circuit that you're going to be doing. And don't forget also the ground. We have a ground here. So this is your branch circuit, and here's a light or multiple lights, for example, and I bring the light, the neutral, to the light, because that's where the light is, and this is the frame, to ground the frame. Everybody understand, when we see a branch circuit, you are looking at a branch circuit, a single phase branch circuit. So voltage at the terminal of the equipment, the minimum circuit will have a long uninterruptible life. So when it comes to the circuit like this, guys, to feed multiple lights, these are CL lights, we said 18 of those. What you need to pay attention to is you need to pay attention to how long the branch circuit is, so you don't have a voltage drop problem. So if you're talking about 20 amp circuit, you can move a 20 amp circuit at its almost rated load up to 70 feet. So if you have 60 feet, 70 feet, so if you have a load further than 70 feet from the panel, the first thing that should come to your mind is that, oops, I might have a problem with voltage drop. So when you start circuiting, guys, you might load the circuit less because of voltage drop. So if you stay within the criteria that we said, 18 fixtures and 6 receptacles, that will, for the most part, get you covered for, I would say, 90% of the time for voltage drop issues. The ampacity of the conductor, guys, is a big deal. That's why number 12, for example, if you look at number 12 that we did right here, that number 12 can carry up to, based on the code, up to 20 amp, non-continuous. If it's continuous, you can carry up to 16 amps. You know, you can load it up to 16 amps. So you're looking at 16 amps of loading that number 12 continuously. Number 12 continuously on a 20 amp circuit. So that's called the ampacity of the conductor. How much current under normal operating condition the conductor can carry. If it's not normal operating condition, then you have to derate. For example, number 12, guys, under normal operating condition when we're sizing non-continuous 20 amps. If it's the abnormal condition, you start bundling them, putting them in more boxes, more conduits. You put them outside in a temperature, you have to derate. So number 12 might not be able to carry more than 15 amps if you group them together. So here's the advice for you guys. When you're in a circuit, I told you how many you're going to do them. And typically we don't, I used to say group 16. If you group 16, you're way far. You don't want to group more than 9 circuits in one, 9 circuits, even 9 circuits or 6 circuits in one conduit. Talk about grouping later on. Conductor type, resistance of the conductors, guys, the material, the length. So that's, for the most part, we use copper. That's your conductor type, THHN. This is rated for 90 degrees Celsius. The length is a big deal, guys. You're looking at 60 feet to 70 feet on a branch circuit. That's on a branch circuit if you're picking certain load. So if your load is more than, even if it's more than 50 to 60 to 70, that range, you might have to start doing a voltage drop calculation. What does that mean? you might end up, instead of using number 12, you might end up with a bigger size conductor. So in a branch circuit or feeder. A couple of things, guys. Conductors have to be insulated, right? That goes without discussion. That's why when you guys were writing for feeders for me, I emphasized one very important thing when I was doing my calc, right? The insulation, THHN. And do you guys remember when it was an equipment grounding conductor, bonding conductor? What did I wrote? Either THHN or bare. Equipment and bonding conductor can be the only conductors that can be bare. Almost all other conductors have to be fully insulated, THHN, THHW, and what's not. There are two types of insulation, Brian, that you're going to be dealing with. One is called thermoplastic insulation, and the other one is called thermoset. So what's the fuss? What's the fuss between these? Anybody knows the difference? Did you guys go? You went through a school with us with electrical. Anybody? The one who went through electricity knows the difference between these notoriously famous ones for them. This goes directly with this. Here's another notoriously famous one that goes with that. Now let me tell you a little thing. 90% of the time you guys are sitting right here. 90% of the time we're sitting at thermoplastic. These are for most of the application that we use, right? There are certain applications that require you. So what's the fuss with this? This one can handle higher and lower temperature range. That's all. So thermoset insulation can get you a higher and a lower limit range versus than thermoplastic. So for example, if you have a fire pump, or what's not, they tend to use, because fire pumps are supposed to work when the building is on fire. So what they use is RHH as an insulation because it gives you more higher temperature. It's rated for more higher temperature. What happens, guys, is this one will soften when you heat this one. It will soften and melt when you heat it. When cold, it will stiffen when you cold it and break down, right? So that if you take a THHN conductor, put it in a lot of heat, it will soften and start melting. And if you put it outside in Minnesota, exposed to more temperature than what's rated for, it will stiffen and it will crack. So both of them, what happens if you have an insulation that stiffen, crack, or soften, melt? Bad news, right? So both of them are bad news. This guy can withstand higher and lower temperature. That's the most important thing. It's the same thing. It will melt at one time and stiffen and crack. Both of them will. But at a higher temperature when it comes to the heat, and at a lower temperature when it comes to the cold. Any comments, guys, about these two types of insulation? Two types of insulation. These guys start with R. Can you guys see that? Or X. These are kind of the indication for the R's and X. These almost always start with T. Can you guys see that? The indication for them. Which one do you use most of the time, Derek, my friend? It's going to be the T, the ones that thermoset. Thermoset plastic, cheaper, and it gives you 90% of the application. When would you pay attention to using others? Fire pumps, high temperature in manufacturing process where they're melting steel in that area, the ambient temperature is so high, so you end up using a higher temperature rated insulation or RHH. Okay, before we go ahead, guys, I'm sure you know that if you have two H's in the name, this is rated for 90 degree for the most part. If you have one H in the name, this is rated for 75 degree, right? And if you have no H whatsoever in the name, like TW, this is rated for 60 degree. Everybody understand that? That's 60, no H whatsoever in the name, rated for the most part. 60, one H, 75, two H's is what? 90. There's some, these are the general, there's some exception. If you have a W in the name, this is for wet location. Let's spell right, wet. So wet location. If it's W, it stands for wet location. So if you don't see a W, this means this piece of equipment cannot be installed with WET, right? That's what I thought, man. That's in French, WIT. Let's pretend it's in French, right? Wet. Okay. Any comments, guys? Any questions about wet? So when you look at these insulation, you see W wet, you see two H's, You're looking at 75. You look 1H, 2H is 90, 1H 75, no H 60, and typically thermoset is the one they're going to be using. Cool. So that's what you're going to be using in these tables. 310.15p16, guys, is you're going to be in this table 90% of the time. I'll walk you through this one. You can have copper, which most of what we're going to be doing. You're going to use aluminum, which typically a lot of them for feeders. This one, you can use this one for branch circuit as well as feeder, right? And services. Aluminum typically for feeders. What's the difference? Copper can give you more amp per square foot than aluminum. What's nice with aluminum? Two criteria for aluminum conductor, guys. They're light, so if weight is an issue, if you have a bigger feeder and weight, physical, mechanical weight is an issue, aluminum will be a choice number one. And cheap, of course, and cheaper. Lighter in weight and cheaper. But you end up with bigger conductors, though. Then they mix the two together and they come up with something called copper-clad aluminum. They fuse them, mix them together, and they come up copper-clad aluminum. The code treat the copper-clad and aluminum are the same, the way they treat them in the code. I can't emphasize, copper wire is the wire of choice. Typically in almost all applications, especially engineering, engineers almost love the copper. So unless you know otherwise, we're designing based on copper. Definitely the branch circuit. Okay, we talked about this one, conductor installation. There's something called conductor installation with multiple rating. So Karen, when you're working in the field, you're going to find something that says THHN/THW. A lot of people use this installation. So right on the conductor, it says THHN/THW. How do you treat this one? If you're using this one indoor, it will be treated as THHW. If you're using that baby outdoor, it will be treated as THW outdoor, THHN indoor. Indoor THHN, outdoor THHW. So can you guys see that? This is my outdoor right here. Why? Because it's wet. Wet location. And this is indoor dry. Does that make sense? In the same conductor. A lot of contractors like this type of installation, guys. Why? Because it combines, if I have a conductor right here, I'm going to poke right through this wall and go outside. I don't have to change the conductor type, right? Isn't that cool? You don't change it. Why can't we use THHW all the time? THHW more expensive. You're going to get more. So that THW/THHN is a good choice for installation. Then you don't have to worry about going inside or outside. Wet location. Every time you hear a wet location, guys, you're looking at a conductor that has to be rated for wet location. I can't emphasize, when you get to wet location, your conductor has to have some type of a W in it or rated for wet location. They call it subject to saturation of water. You can think of many places. Outdoor, guys, right? Any place outdoor is exposed to the element saturated water. Indoor, car washing places, any place where you use water to clean things is saturation of water. Who cares? When it comes to sizing your conductor have to be THHW or has to have a W in it, okay, if it's a wet location. Any comments, guys, any questions? So typically underground, outdoor receptacle, equipment and branch circuits, outdoor, indoor, saturation of water. Yes, sir.
What you're saying, what about if you had a conductor that was going inside?
Went out.
And it went out?
The minute that baby gets out, now if it gets out to feed a lighting fixture, like you poke right here through this wall, and there's a lighting fixture there, that's okay. Just right in tied to the lighting fixture. Now went out and kept going out for a foot or 2 or 3 or 10, you have to change the conductor into a THHW. But here's the nice thing is, if you have double installation conductor, you'll get THHN/THW. That's what a lot of contractors use, guys. So now I'm walking here, feeding all these lights. I want to go pick up a light there. Continue. Why? Because it's rated for inside or outside. You see what I mean? So that's a double insulating. Or if you're using THHW, just one conductor, THHW, then you don't have to worry. You can use it inside or outside with your dam location. Does it make sense? Okay, for conductors, guys, I think this has changed. I don't know why we still have it. Table 310.15 B16 will give you all the ampacity for conductors. The type of the conductors that you can get, are in table with table. Where's my table? 310 dot something. Okay. It used to be in that location, so they change it into table at the end here. There you go. Table 310.104. This is 310.104. Is there a C on it or something? Yeah. 310.1048. That's that. This table, guys, I'm going to show you in a second here, has all the insulation ratings. So you don't have to memorize what I told you. Your code is in the front of you. You can go there and you find all the insulation. 110.15b16 is you're going to spend 90% of the time using this. I'll show you how to use it in a few seconds here. Okay, so here's my my insulation type. This is coming directly, guys, from. I'm going to go directly here into disregard this and go to the NEC code book. My NEC code book. Okay, let me see if I can open new. 1 second here. Okay. Oops. Went too far. Too far. Okay, let's go to the NEC code book, guys. If you do me a favor, can you please open your NEC code book to that location? Thank you. So let's go to 310.3. Let's go from here. It's easier to get to it from that side. So here's the. There you go. Here's the table that we're talking about, guys. Right in here. This is the table that give you all the types of the conductors that are approved in NEC code book. So I'm going to walk you guys through the most important types. Everybody has their NEC code book, guys, handy? Yes. This is page. Which page is that? This is page 168. 168, please. So if you guys go to. Here you go. Let's start with RHH. Can you guys see that RHH here? RHH, it's a thermoset. It's rated for 90 degree, dry or damp. They can make them from number 14 all the way to 2000. And there's a couple of description of the jacket that they put on them. And it's a thermoset. I can't emphasize, this is very, very important table, guys. It gives you the characteristics of the conductors that you're going to use. Let's go to something very familiar, guys. THHM. Let's look at the THHM conductor. Right in here is my THHM conductor. The most common one that you guys will be using. It's a thermoset. I'm sorry, thermoplastic. Let me see if I can get it to blow up a little bit more. Here you go. So this is my thermoplastic type of insulation. It's called THHM. It's rated for 90 degree in a dry or damp location, flame retardant and what's not. The size that you can buy it from number 14 all the way to 1000 volt. And it has some description of the jacket, nylon jacket, and all the dimensions, the mills and what's not. Can I have thumbs up, Chad? We fully know how to use this table. Karen, start with Karen. Cool. Brian, this is so important, guys. Any installation you can find. Can I use the attention in a wet location? No. Why? The code doesn't say wet location. Okay, right underneath it, guys, here's the HW. We were just talking about this. This baby can be used as 75 in a dry and wet location. Dry and wet location. Only for special permission you can use it at 90. So dry and wet location 75, you can make them from 14 gauge 14 to 2000 KCL, gauge to 14 to 2000. One more time. Any comments, any questions, guys, about this installation? Now here's my. Now you guys will be in a situation. Okay, so what happened if I don't know the installation? So I have an installation I have no clue what. Here's a TW. I don't know if you guys can see that TW1. and all UF cable, all the insulation they use in the US is right in here. XHHW, XHHW right here. That's thermoset insulation. You can see that one. It's rated for 90 degree in a dry and damp location, 75 in a wet location. Can you guys see that? Double rated. One 90 degree in dry and wet location, 75 in a wet location. 90 degree in a dry and damp location, and 75 in a wet location. The sizes that you can make them is 14 all the way to 2000. Before I leave this table, any question guys about this table? You will be using this table this semester, next semester, and when you go to the also to the motors, we're going to be using identifying the insulation of the table. If you ever seen an insulation that you have no idea what it means, ZW. What the heck is a DW? I have no idea what ZW. Okay, no problem. ZW. It looks like it's rated for 75 in what location? It's in a damp location. You can use it at 95. And special application, you can go as high as 150. They make them only from size, it looks like from size 10 all the way to size 2. No jacket on them. So it's special cables. One more time before I leave this one. Everybody's okay with this table, guys? We're cool? Cool with you knowing this table? Okay, so that's my installation. Moving on, guys, into when it comes to electricity, heat is the most important thing, the enemy number one of electricity, like I always say. Excessive heat, guys, will degrade. When you have an excessive heat, it will degrade your equipment. No question asked. So that's why you have temperature rating of the equipment. Degrades and destroys your insulation. You guys, excessive amount of heat. Everybody understand why temperature rating of conductor is a big deal? 90, 75 degrees Celsius is because of heat. Okay, we talked about this insulation a second. Ambient temperature. Ambient temperature, guys, if your ambient temperature other than 30 degrees Celsius, you are to derate your conductors, and we did calculation for derating conductors. So you are supposed to derate conductors for both copper and aluminum if your conductors are they're other than 30 degrees Celsius. And we'll look at some of these derating tables. If you have conduits on the roof exposed to the direct sun, you always have to also derate based on this table, guys. So let me go to the NEC code one more time, and I would like you guys to highlight this one directly in the NEC code book. So let's go to the tables all the way up to table 310.16, will you? 310.16. Thank you. 310.16. There you go. No, not here, Chad. Okay. Now I want to start right here, guys. Do you remember when we did the residential? We told you to go to this table. This is the table that I told you guys to highlight, and don't go without. That table was for dwellings, and we said if I have a 400 amp panel in a dwelling, we can go directly to a 400 kCm. That was for dwelling only. You're going to forget about that one. We're not dwelling anymore, right? Everybody understand? Now the table, your table of choice, it's going to be this table, 310.16. So let's go directly, guys, and say a few things about this table, please, and write them down for the use of this this table. And that's what I always say. Highlight this table is going to be your baby. This table, guys, is used for conductors. The first thing is, if you look at this table is based on 30-degree ambient temperature. The ambient temperature is 30 degrees Celsius. If your ambient temperature is different than this, you're supposed to derate. Cool? So that's how we start. Ambient temperature, 30. The most important thing is the ambient temperature. And if you guys look here, not more than 3 current-carrying conductors. It's only for no more than 3 current-carrying conductors. If you have more than 3 current-carrying conductors, what do you need to do? Derate again. You need to derate. Okay, based on the insulation, guys, you can either go 50, 75, or 90. So if I'm THHN, I'm right here. So let's go, guys, directly into number one. Number one, THHN can carry this amount of current, 145 amps, 145 amps. If it's THHN. There's a couple of things, guys. Anybody knows how, do you know how to use this table? Do you guys know which column to go to? Which column would you go to? Do you know the rules if you don't know the installation, the logs, and what's not? So let me just go quick, guys, to here. Let me go back before we do the logs. Oops. There you go. Let me highlight this one when it comes. This one directly from your book, guys. Look at the rules for using this table. Very, very important. If your equipment is rated for 100 amp based on the logs, if your equipment is rated for 100 amp or less, or if your conductor is 114 or less, you have to go to the 60-degree column. Can you guys see that, please? That's the most confusing part. If your equipment, this is a receptacle tied to a circuit breaker, and you have no idea, you typically have no idea what the logs are, you're going to use, if your equipment is rated for 60 degrees Celsius, can you guys see 60 degree here, and 60 degree here, and 60 degree, what do you think the conductor is going to be rated for? 60 degree. So which column are you going to go to in that table? 60 degree column. If your equipment, look at this, conductor with higher temperature, so now I have terminal 60 and another terminal 60 and a conductor 75 or 90. When you do the ampacity, which one? The smallest, you're going to go to the 60 degree. Here, you're going to go to the 60 degree. Can you guys see that? Why? Because you go based on the weakest link. When it comes to ampacity, guys, there's something called the weakest link. The weakest link is the lowest temperature rated of the logs or the conductor. So I have log 60, 60, conductor 75 or 90, weakest link is 60. Done. Look at this. I have a piece of equipment that logs are rated for 75 from both sides, and the conductor is rated for 75 or 90. In a case like this, you can go to 75 degree column. You can go to 75 degree column. Okay? For motors, guys, this is design B, C, and D. Motors design B, C, and D are always defaulted with these type of installation, right? And then you can use 75 degree column. Guys, if you're to stay in this industry and work it, probably this is the most misunderstood thing. I teach the exam prep for people who go test to become a master and journeyman. If you don't understand this one, you would never understand which column to go to. Let me give you the little secret that makes your life easier. If you're dealing with three-phase system, 99, you're dealing with three-phase system. 99% of the time, you're dealing with this. So which column are you going to go to? If you're dealing with three-phase system, size based on 75. But what are the rules? The rules are, if your equipment is 100 amp or less, or your conductor is 14 through 1, and you have no idea what the logs are, 60 degree column. If your equipment are, so that's, if your equipment, and then if your conductor, regardless of the conductor, if the conductor, like here, my conductor here was TW, okay? This is THHW or THHN, regardless, right? Any question, guys, about the rules? Which column to go to? Any comments, any questions about the rules and which column to go to? This is the most important thing that you're going to encounter. The second one, guys, here's another example here. Remember, the motor at the bottom are always 75. That's how they rate them. Then you go to the second rule when it comes to this table. The second rule, if you have a piece of equipment over 100 and the conductor is larger than number 2, your default is 75 degree column. And of course, look at the conductor 75, insulation both ends 75, you go to 75. You can use a higher temperature like 90 here, doesn't matter. You can go to 75 degree column. Any comments, any questions? Which column are you going to go to when you go to the table? So let's go back into this table now. Here's a question. You guys put you on the spot, huh? See, You have no idea about the logs, and you have number 6. What's the ampacity of number 6 based on these rules? Is it, what's the ampacity of number 6 based on these rules? The conductor, you have no idea what the logs are. The conductor is smaller or less. The ampacity, your default ampacity, guys, is 50. If your conductor is number 1 out, now larger than number 1, your default ampacity is immediately jumps into 150. So for all these conductors, guys, your default is always here unless you know otherwise. For all the conductors down here, your default is always here unless you know otherwise. And you can see how they go. So if you have a 500 kcm conductor, where do you go immediately from the get-go? To 75-degree column. There's something called small conductor rules, guys. You're going to use them all the time right in here. These are called small conductor rules. For number 14, you shall not use more than 15 amps. For number 12, you shall not use more than 20 amps. For number 10, you shall not use more than 50 amps. You can't do that one for any of these. Any comments, guys, about the small conductor rule? So for your conductor, number 12, regardless, can I put a 30 amp on number 12? No. Exception for these is what we call it Morse. Now the last column, guys, is this column. When do I use this column? This column is used only for derating. This column is only used for derating. Any comments, any questions? Any question, guys, about this table? This is, like I said, is the most important table in the whole code book. All the rules and determination, it's based on the rules of determination. Here's that dirty secret, Karen, my friend, is 75% of your time, probably 90% of the time, if you're doing industrial, commercial, 3-phase, you are in the 75 column. You are in the 75 column. Any comments, guys? Any questions? Any comments? Any questions about that? Comments, questions? Does it make sense? Yes, no, Derek? You guys know how to use this table for Bryant circuits and feeders and what's not? Like I said, 90% of the time, if you're doing industrial, commercial, you're 75 anyway. So you don't really have, you rarely, if any, you have to be a really a not so bright designer to use a TW conductor in a commercial industrial building. Okay, now with this table, guys, I'm going to go just quick here over bundling. If your conductors are more than 3 current carrying conductors, then you have to derate. Here's my derating table. If your conductors are, this is for 3 carrying conductors. If you have more than 3 hots, 3 conductors, 3 hots, you have to derate based on this table. For example, let's say we have 12 circuits. The 12 circuit, guys, give me a 50% derating factor. So here's a number 12. If you guys take it to 90-degree column in 310.15 P16, that will give you 30 amps. If you derate, there's a 12 of these. All of them are hot. Then you take the 30 and multiply it by 0.5. That will give you only 15 amps. Can I have thumbs up, Chad? We know how to use this table. Yes, no? You go to the number of conductors, and based on the number of conductors, it gets you hot conductors, give you a derating factor. You go get the ampacity from wherever the insulation is. It's T, H, H, and have it here, and you derate it. Any comments, guys? Any questions about how to use the derating table? Now, this beautiful conductor that's supposed to be, guys, carrying 30 amps, no, cannot carry more than 20 amps. Because I bundle them. How do you bundle them, Matt? You bring a conduit and you pull 12 conductors inside that conduit. That's called bundling. Any comments, guys? Any questions about bundling? Here's another example. Let's take let's just take number 10. I have number 10 conductor, T, H, H, N. And I have, let's say I have 9 of them. 9 number 10. What's the ampacity, guys, for number 10? 9 number 10. 9 number 10. Anybody? What's the ampacity for 9 number 10 from 310.15? 9 number 10. under 90-degree column. 90-degree column. 40. Anybody disagree? Okay, here's a 40 amps under 90 degree. 90 degree. Now, for 9 of them, guys, I have a derating factor of 0.7. So you take the 40 and multiply by 0.7. Matt, do you have a calculator handy? What's 70%? How much? 20. 20 amps. So now that conductor, number 10, cannot carry more than 28 amps under these circumstances. Straightforward. Any comments, guys? Any questions? Any comments? Any questions? Comments, questions about that, the rating based on temperature. So that's based on temperature. Now based on, okay, don't want to do it now. Ambient temperature, guys, is if your ambient temperature, I want you, Matt, to keep in mind that the two conductors that we just used, will you? Let's go to the derating, go to this table, guys. That's a table that you derate based on temperature. Please highlight this one. It's a crime against humanity if you leave done with it without knowing how to use it. So here's my conductors. Let's use that number 9 conductors. Number 10, A, W, G, T, H, H, N. Okay? So let's suppose that this is, guys, derated. This number 10 was the table. What was the ampacity of that conductor, guys? You just gave it to me. From under 90 degree, from 310.15 P16, 40, right? Because everybody knows that. That's 40 amps. Now 40 amps, if the ambient temperature is 30 degrees Celsius. 30 is hot, by the way. 30 degrees Celsius. If your ambient temperature is different than 30 degrees, then you have to derate. Okay. Can somebody give me a so ridiculous ampacity? Very high ampacity. Pick any high. The Fahrenheit or Celsius. Let's do the Fahrenheit because we're familiar with the Fahrenheit. Let's use this this ridiculous high ambient temperature. Shall we? 150 to 158. That's hot, Fahrenheit. Shall we? Suppose that you put this conductor, guys, in a place, in an industrial plant where the ambient temperature is hot, 158. Okay, based on this one, guys, the insulation is 90 degrees. Then your derating factor, they call it derating factor, is what? 0.58. What does that mean? Means that beautiful conductor of yours now no longer can carry. You take this 40, multiply it by 0.8, 0.85. Adam, what do you have? 40 times 0.58. Anybody has a calculator? Adam? How much? 23.2 amps. Okay? 23.2 amps. Any comments, guys? Any questions? Now that's if all this is only if there are 3 conductors hot. If there's 3 conductors in a conduit. Now let's make it more ridiculous. Let me just tell you how important that one. Any question about this one, guys? 3 conductors, number 10, 40 degrees, 40 times 0.58, give you 23.2. Now let's make it more ridiculous, right? Let's try to bundle them. Did you guys hear me? Try to put them in a conduit. So let's put 9 of them. I'm gonna go do 9, number 10. A, W, G, T, H, H, N. Okay, under the same circumstances, except I put 9 of them. Can you guys see that what happened next? Then you have to take first, you take your 40, multiplied by, what's the derating factor for 9? Because you bundled again, 0.7. Then multiply again because the ambient temperature is bad, multiply this by 0.58. And Adam or somebody, Karen, can you guys do the math for me? 40 times 0.7 times 0.58. I'm trying to tell you how ridiculous things can be when you bundle the conductor and put them in a very hot temperature. It becomes completely ridiculous. Now remember, we started with 40 amps. How much amps are we left when we put that conductor under these circumstances? How much? 16.24, 16.3 amps. Gentlemen and ladies, I would like you to look at this. We started with 40 amps because I decided to put them in a conduit. Look what happened. 9 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 in one conduit. And I decided to put them in a temperature of 158 degrees Fahrenheit. Now that it can't be more ridiculous than this. And I have 9 conductors in the same conduit in a very hot temperature. All of them are number 10. So we started with 40 amps, and what did we end up? With 16.3 amps. What would that tell you from a design point of view? If you guys have a hot temperature, do not bundle. If you don't bundle them, look how much we got. We got 23.2 amps. If you don't group them together. What bundle? See that conduit there? Just don't put them in a conduit like this. Put them in a separate conduit. Any comments, guys, any questions about bundling? They call it bundling and temperature, the rating based on temperature. So that's why when we pull your conduits, guys, typically you don't want to put more than 9 conductors in one conduit. In a normal ambient temperature, under a normal ambient temperature. Any comments, guys? Any questions about that? Does it make sense? So that's it. Well, that's what the rating based on temperature and the rating based on bundling. I'm going to go down and say the smarter than Chad. So that's how you use this table, basically. Now, it's even to make this more ridiculous. Imagine if you use, instead of using Chad, let's go use TW. Talk about ridiculous stuff. Just look at that. Use TW. For TW, guys, can you guys see the 60-degree column? Actually, do you see any value here? Do you see any value here? They're telling you you can't even be ridiculous even if you want to. What does that tell you when there's no value here? Don't even think about it, right? So if I want to use a TW, I don't have a derating factor here. It says it's not worth doing the derating factor. You're going to lose so much ampacity. Might as well use a barbed wire to carry the conductor. So I don't even have it. Cool. Now, if up to that temperature, that's when they start giving you a factor. Because after this, here and down here, why they don't have them? Because you're losing so much ampacity, that's not even worth doing the calculation. Does that make sense? How this table is rated. That's my calculation. Now, what happened if this is the calculation and ambient temperature. Now, the smarter than Chad came and say, guys, right in here, they said, they call it the error. This little table, if you go on the roof and you put a conduit on the roof, mount it like this on the roof to feed equipment, then this conduit will be cooked with 2 temperatures, the direct sun temperature as well as the reflected heat. Direct, reflected. So the smarter than Chad say, okay, give me a number. You want to how high you want this block to be? Shall we say, well, let's say 6 inches, right? 6 inches. We're going to off that roof, 6 inches. Okay, 6 inches will put me where? This is up to 3.5, 6 inches. I'm right here, right? Is that what I am? In terms 3.5 to 12 inches. 3.5 to 12 inches, I'm right here. Then I have to add more temperature to my ambient temperature. Can you guys see how many ambient temperature I have to add? 30-degree ambient temperature. Why? Because now my conduit not only will be cooked by the direct sun, but also will be cooked by the reflected sun from the roof. So your ambient temperature have to increase by 30%, by 30 degrees Fahrenheit. What does that mean? Okay, keep that 30 in your mind and let's go back to the table that we were just looking at. Okay, let's look at that table. Now keep this in mind. Now my 30, now the same calculation here, I will remind you, here's my conduit. Now because I have to add another 30 degrees Fahrenheit. Now let's say we are in Arizona and the ambient temperature outdoor was, let's say ridiculously hot this year, let's say just this, 140, right? That's the ambient temperature. Now, if you put the conduit right on the roof, you add more even. So look what happened. Now I have to add, so my ambient temperature say was 140. I have to add plus 30. Cool. So 140 plus 30 give you 170. Now I move from here down into 170. Where's 100, 140? 40, we're 170 right in here. Can you see what happened? If my ambient temperature was 140 degree Fahrenheit, my ambient temperature, add 30 to it, it shifts me from here all the way to here, and look what happened to the factor. My factor went from this to this, from 0.71 to 0.41. What does that tell you? It's more ridiculous. You're going to lose more amps. I cannot drive enough that concept for you. I cannot drive the concept of the ampacity enough for you. Any comments, guys? Any questions? Any comments? Any questions about derating and ampacity? So these are the table that in that chapter that emphasize a lot in that chapter. I'm going to give you guys 5 minutes, and I'm going to continue with this chapter because it's so important. Shall we have 5 minutes, please? Just go stretch, and let's we'll get back. There's a couple of things I want to highlight in this. Okay, so we talked about this table, guys. I hope I like to always go to the NEC code book when we talk about all these tables. I hope you appreciate that. So we talked about this table and derating. You went there, that's ambient temperature added to the roof. So that's what we were talking about in conduits and what's not. Adjustment factor for more than 3 carrying conductors. Gentlemen, we just were there and we did adjustment. Penalties. So that now if you have high temperature, if you have 3 current conductors and heat or high temperature, you're going to adjust both of them. That's what they call it the ridiculous. When you derate based on temperature and based on bundling. We did that one. Here's what bundling, guys. Look at this. I mean, I can't emphasize, Matt, when you're designing a building, guys, you're designing it for 40 to 50 years, right? Do you really want the conductor to be jammed and hot and malfunctioning for 40 to 50 years? That's why all these rules in the back of my mind. When I design a hospital, you're looking at a system that's probably will outlive most of us, right? So that's where all these rules are supposed to help you. Now, there's one little thing, guys. It doesn't come often, but if you have a conduit, in an ambient temperature, and that conduit is more than 10 feet, 10 feet of it, if 10 feet of it in an ambient temperature of 90 degree, let's just use a different temperature. Okay, so if let's just say 130 degree, and the rest of it from here to here is under degree Fahrenheit, and 86 degree Fahrenheit, the rest of it. Here's what the code says. If 10 or less, or 10% of this conduit or less, in a higher ambient temperature, you can use this ambient temperature. Did you guys hear me? So if I have a temperature, if there is 10 feet or less of that temperature, or 10% of the length of the temperature or less, in a higher ambient temperature, use this higher ambient temperature. That's what they're saying, this 10% or of the total circuit, not more. So in a case like this, right, I can use the ambient temperature 130 degrees to size this cable. Now, what happened is, if I have 11 feet, let's just say a scenario, I don't think I can. If I have another scenario where I have this section here is 11 feet, right? Then I have to use, I'm sorry, this one 130 degree, I meant to do this one 86. I mixed it up. So the one that with the highest degree, come on, disregard it. I can't erase with this one, that's bugging me. Okay, so with that, so the one with, here's the rule is, not more than 10 feet and not more than 10%, then you go lower, higher ampacity. You can use the high ampacity for the circuit. So if that's your situation, you go, if you have a conduit, 10 feet of the conduit is in a high temperature and the rest of it, another 20, 30 in a lower temperature. You use a lower temperature, right? If 11 of it is in a higher temperature and the rest of it, 30, is in a lower temperature, you have to use the higher temperature now for the roof. So anyway, pay attention to this rule, guys, of 10% or 10 feet. Doesn't come often. If your conduit is a nipple, what we call it, 24 inches or less, so you have a 24 inches or less, guys, you do not, and you bundle that, you don't have to derate. For example, I have a conduit, pull all my, they're 24 inches or less, I don't have to derate. Not more than, so you don't have to derate based on bundling. You can put as many of it as you can without derating. Equipment effects, conductor selection. Okay, we talk, many conductor had dual rating. We talked about dual rating. Okay, another thing, guys, is keep all the conductors in the same conduit. So here's my conduit here. Because of induction heat, when you bring circuit 1, 2, 3, and a neutral. So here's my phase A, phase B, phase C, and a neutral, and a equivalent grounded conductor and a ground. This is an EMT conduit. So Karen, all the conductors have to be in the same conduit because of induction heat. You guys, if you talk to people in the field, there's stories. If you have one conductor, only one phase in one conduit, you know what happened? You created an inductive heater. So the magnetic field start inducing heat into the conduit, and there's stories of the conduit glowing. It glows, becomes very hot. The only thing you need to remember, what you need to do is when you have a circuit, all the phases of the circuit, including the neutral and equivalent ground conductor, must be bundled in the same cable or the same conduit. So can I take one phase of one circuit and put it in a conduit, another phase of another circuit, another conduit? No. All of them have to be in the same conduit. Why? Because of so-called inductive heat. If you want to create yourself an inductive heater, so all what you have to do is just bring a phase, put it in an EMT conduit, steel, and energize it from one end, and you go touch that conduit, and you're going to see it's getting hot and hot, depending how much current you can do. So obviously, this is not what you're trying to achieve, creating heat when doing it. Okay, when it comes to circuit, guys, the overcome protection device is so important to decide. Here's how we go for most of circuits. If this is continuous load, if this is your continuous load, the overcurrent protection device, guys, overcurrent protection device, when you size it for continuous load, you take the amps, I, of the load, this is I, load, and to size the conductor here, you multiply 1.25 times I, and to size the overcurrent protection device here, you multiply 1.25 and you times it by I. Any comments, guys, about sizing the overcurrent protection device for equipment? Very easy. You guys have done it with me for your load count. If your load is continuous, you take the continuous load, multiply it by 1.25, get you the conductor, and 1.25 get you the overcurrent protection device. If your load is non-continuous, same thing. Here's another piece of load over current protection device. This is non-continuous load, and my load is I, is my load. All what you have to do is size your conductor based on I, and your overcurrent protection device is based on I. No 1.25. Can I have thumbs up, Chad? We know how to size the overcurrent protection device for continuous load. 1.25 overcurrent protection device and branch circuit. Non-continuous, you don't have to do that. Overcurrent protection device, guys, is there, the circuit breaker or the fuse, to protect the conductor as well as the equipment. For the most part, the conductor, but in a sense, it provides some protection for the equipment too. Abbreviate component, the motor. Let's look at this one. Here's a nice table. Please go refer to this table all the time because it will help you in this project and next project. So Karen, if I have a continuous load right in here, when I size conductor ampacity 125, minimum overcurrent protection device 125, the maximum you go to the next standard up over the conductor ampacity. Okay? If you have a hermetic motor compressor HVAC equipment, not smaller than the minimum circuit ampacity on the nameplate. Overcome protection device, not lower than the minimum overcome protection device, and it has to match the maximum overcome protection device on the nameplate. Non-continuous, can you guys see non-continuous? It goes exactly by the load. Next standard higher you can go. If you have a motor type, your load, your conductor is 125. For overcome protection device, there is a whole table, guys. You did calculation with me, and you can go to the next standard for the most part on it. Cordon block, if you have cordon block circuit, not less than the overcome protection device protecting it, not less than the load, the minimum, and not higher than the conductor ampacity. Can you give me a thumbs up for two things? Number one, if you're continuous load, here's how we size it. If it's a motor, this is how we size it. Any comments, guys, about this? Karen, let's start with Karen. Any question? I don't want to reach, guys, the industrial project and somebody looking me in the eye and have a continuous load and not multiplying it by 1.25. That's what happened. So it's so important, this, guys. This is how it's very easy. Your continuous load 1.25 for both the overcome protection device and the conductor. If it's hermetic motor, you guys did it with me last project. Your nameplate will have the conductor size, that's like HVAC equipment, and the overcome protection device on the nameplate. If it's motor, continuous load, the same thing, and overcome protection device varies from 1.75 all the way to 2.5 and 300%. Any comments, guys? Any questions? Questions about that? So please, I can't emphasize, guys, going over this one. This is what you guys are going to be doing with me. You're going to be laying out your receptacles. Here's my receptacle. 1, 2, 3, 4, 5, and 6. And we're not going to do spaghetti, guys, on this wall. And we're going to be when you guys circuit them, it's going to be receptacle panel dash 1, receptacle panel, and circuit 1. And this will be a receptacle panel 1, receptacle panel 1, receptacle panel 1, receptacle panel 1, and tag all of them. Receptacle panel 1, receptacle panel 1. So in Revit, Karen, when you drop your receptacle and you circuit them, you're going to tag these equipment with a tag. Remember how we tag the name of the equipment, Matt? And we tag it with a name. Your receptacle will be tagged and circuited. In reality, they are all grouped together here, and they're going to a circuit, to a certain circuit. That's what you lay out your branch circuits. How many receptacles? We said we're going to put 6 receptacles. Maximum 13. Where does the 6 and 13 came to be? Grab your calculator, Derek, will you? Here's a 20 amp circuit. Let's use this 20 amp circuit. Okay? And let's use receptacles. For receptacle, guys, every receptacle is assumed 180 volt amp. Okay? So in order to find how many number of receptacle on a circuit, take a 20, multiply by 120, will you? And divide it by 180. Can you guys give me the number, please? 13.3. Derek, since when we have a 0.3 over receptacle? We don't. So what do? That's where your 13 is coming from. That magic number 13. Now, that's the maximum. Do we want to go to the maximum when we design? No. So what we typically do, guys, for design-wise, we cut it by half. Because receptacles, you can't control what's plugged into it, can you? Can you control what people plug in these? You can't. Lights, you can, though. Now, how often people go and plug things in up there? How often? You really have to be kind of either messing with things that's none of your business, or you're an electrician and hopefully you know what you're doing. But here, do you have any control what's plugged in here? So that's why we're receptacle in the commercial industry. We try to cut them. Again, so we go from 6 to 13, somewhere heavy medium. Okay, so that's your circuit. We talked about how to size. I showed you guys how to size the equipment, minimum number of branch circuit. So what they do is, for lights, for example, they take all the volt amp of your light divided by 120 times 0.8 times 20 amp, and that will give you how many minimum circuit. Here's how the calculation for lighting circuit. Can I tell you guys how we did the calculation for lighting circuit? Here's a 20 amp. Here's your light. That's my light. These are also number 12. Remember, number 12. Now, For lighting circuit, guys, to find how many lights, take this. You take a 20 amp multiplied by 120. But here's the deal. So lights in a commercial building is continuous load. So you don't want to load the overcome protection device atom for more than 0.8, right? So 0.8, and then divide it by, okay, here's the deal. That's how much volt amp you can get in a 20 amp circuit. 120 times 20 times 0.8. Why 0.8? Because it's continuous load. No, don't load it more than 0.8. Then you're going to divide it by the number, the volt amp of your fixtures. How do you know the volt amp of your fixture? Guys, in a commercial building, a volt amp of your fixture can go from 50 all the way to 250. Here's a rule. For the most part, especially these days with the LEDs, my rule of thumb is use 100 volt amp. Why? If you look at that fixture above your head, it's 86 watt. With a power factor, pump it up probably to 90 volt amp, right? Most of the fixture, on average, that we use in a commercial building will be 100 or less. So I use 100. Do me a favor. Can somebody does the math here? Take 20 times 120 times 0.8 times divide by 100. 20 times 120 times 0.8 divided by 100. Anybody? Adam, do you have your calculator handy? 19.2 amps. Right? Anybody disagree? Okay. That's the maximum that you can do. Now, obviously, you don't want to load it up to 19. So that will be 19 your maximum. When I told you guys to throw 17 on it, we said we're going to throw 17. That will be allowing yourself in the future to add 1 or 2 lights on the branch circuit. Any comments, guys? Any questions? So if you know you have LEDs, by the way, if you have LEDs and your LEDs are 20 watt each, you can almost put 100 of them on a 20 amp circuit. You guys hear me? That number here is an average. And this with LEDs, that's way oversized for a LED light. That's assuming each one of these fixtures above your head is 100 volt amp. And typically for fluorescent light is good assumption for indoor lights. For LEDs, you can cut this easily by half. So an LED, I can cut these down to 1/4. Typically, I probably can put almost 50, 60 fixtures on one 20 amp circuit, LEDs. Almost 50. But do you really want to put a 50 fixture in a 20 amp circuit? You know what a 50 fixture in one 20 amp circuit? This room, and the multiple rooms all in one circuit. So if I turn the circuit breaker here, I lost light in 3-4 rooms. Is that a good idea? No. Do you see the difference between can and good idea? So typically, guys, when you throw 17 fixtures, like a room like this, count them. Even if you have less than 17, it's a good idea to put it in one circuit. Count all these fixtures, put them throw, even if they're less than 17. Because you don't want to group in a commercial building multiple locations with one lighting circuit. Okay, so that's my lighting circuit. Actual number. We talked about the continuous. If you have continuous load like light, you cannot load it more than 80%. Switching arrangement and convenience of installation. That's the convenience of installation, and switching arrangement is a major part. Just because you can put 17, 19 fixtures on one branch circuit, should I do it? When you start laying out your fixture, Derek, you might not do it because it might not be a good arrangement in terms of switching them and what's not. Okay, this is how you determine the number of circuits, guys. Number of circuits and load per circuit. Determine overcome protection device and verify the conductor. That's what we did for the 20 amp circuit. I'm going to go directly, so that's all I have here, guys. I'm going to go into my sheets here for a second. Show you a couple of things that they're doing. We talked, let's go directly into this here. Okay, right here. So just a couple of pictures I'm going to go, and then I'll wrap up, guys, this topic for the day. Well, it's not working. Did you screw it up, Brian, today for me? Okay. When you put things on the roof, remember how the rating based on the roof, guys? That's what they're meaning. Rooftop units, can you guys see that conduit? You have to add temperature because they're being cooked by two things. We got that. If you bundle the conductors, look at this. If you bundle cables, depending on what type of cable and for how long, if it exceeds 20 amp circuit, if the circuit exceeds 20 amp circuit, guys, you can also have to derate them. NM cable, more than 12, you have to derate them. For NM, more than 24 inches here, you have to derate them. If you cock here, guys, for NM cable, you close that one. We're not in an NM cable. If you put cock, you have to derate them. If you don't cock it, only if it's more than 24 inches, the group together, you have to derate. This is how they, Adam, how they test you in the German exam. All these little exceptions. You guys are not going to be that picky in terms. Typically, I leave this one to the electricians, but be aware if you put more than 24 inches cables bundled together, you have to derate. No, these are not conductors, just cables. Okay, if you have a circuit like this one, guys, the current, the two hots coming, this is phase A, this is phase B, the neutral will be carrying current. The neutral will be carrying current here too, right? Why? Because phase B, the other phase, which is supposed to be, here's another light, you grab the phase A, B, phase C, here's my phase C. Can you guys see this? This is how we wire in a three-phase circuit, in a three-phase system. I can't emphasize, I have students that reach industrial, and they still don't understand how the three-phase system works. There are three lines, you take one line with a neutral and feed the lights or the receptacles. For residential, we have two lines, we take one line with a neutral and feed other receptacles. We talked about that terminate. I can't emphasize, Adam, looking at these guys, the termination, very, very important. The only thing I want to say, guys, is for us, probably 90% of the time we're going to be right here. 90% of the time for feeders, it's going to be right here. Meaning the lugs are rated for 75 on both sides, and we're definitely using this type of insulation. So if you're having three-phase equipment, you don't have to worry about 75. What becomes an issue when you have a single-phase equipment, guys, then the lugs might be rated for 60. Talked about these. Harmonic loads, my friends. If you have harmonic loads in a three-phase system, they will add up on the fluorescent light, for example, is notoriously famous. So that neutral on, look at these. I believe they have electronic ballast, but I'm not sure. They might have electromagnetic here. These ballasts equipment, guys, each one of them is 100, 100, and 100. This should be 0, right? If this is a three-phase system, you guys learned three-phase system with us, right? Did you? You did not probably, but you did the three-phase. The reason why we have three-phase system, because if you balance the load, the neutral will be 0. Except if you have harmonic loads. The harmonic loads act differently, they digest electricity differently. So what they do, they cook it in a way where at the end you will have actually the same amount of current going back. So here's 10 amps going this way. There will be another 10 amps going the other way because of non-linear loads or harmonic, non-linear loads. What does that mean? Two types of loads. Certain type of loads, guys, act properly. We have a whole chapter about nonlinear loads. Others, I call them sloppy eater. They digest electricity in a different way that create more current than a neutral. What does that mean? When you bundle this circuit in a conduit, guys, you have to calculate them as 4 current carrying conductor. These are 4 current carrying conductor. The neutral counts. Okay. This is the neutral in a single-phase system that carry the unbalanced does not count. We don't have a single-phase system. So, for example, this is a single-phase system. See how we wire with single-phase system? 50, this amp would not count. So these conductor count as 2 current carrying conductor in a single phase because the neutral is carrying the unbalanced. Wait until you sit for a German exam. They'll catch you, but you guys are not sitting for a German exam. For motors. Here's how we do the circuits for motors, guys. When you size your circuit, branch circuit, Brian, for motors and machines, a branch circuit, a conduit, a branch circuit. That's what we do it. The best way to do it, guys. These conductors, the phase conductors will be sized based on 1.25 times full load current. The overcurrent protection device, which will be right in here. These will be sized, guys, from 1.75 to typically 2.5 times full load current. And you, gentlemen and ladies, have done a few of these calculations with me, right? For branch circuits. So what I would do, I put a conduit around these babies and glue them together in one conduit. Don't put anything else with them. Unlike lighting circuits and receptacle circuits, you can group them. These, the best way to do them is shoot them in one on conduit. Could I group them? Yes. Why wouldn't you group them? First, you have to derate if you group them. Second, if one of them, if this is air handling unit or if one of them burn, it will burn the others. From a reliability point of view, you don't want to do it. Okay, there's something called short section of a conduit, guys. Very, very important. Look at this. I have a short section of a conduit defined by the code 24 inches or less. Right into this conduit, no bundling, derating. So you don't derate. You can pull as many conductors as you want here, as many conductors between these two as you want. Let me remind you where we're going to use this one in this project. If I may remind you, this is what you guys are going to be doing. We're going to have a lighting panel. We're going to have a lighting control panel. You guys are doing with Chad for your project exactly the same thing. We have a lighting panel, lighting control panel. So the lighting panel will have the circuit breaker. It has to, you bring it here, you put it on a contactor, and you bring it back, and then you go back to the lighting fixture. Well, that's one way of doing it. And then the neutral will be coming from here. So how many conductors you are mapping in? You're using them to, this is my contactor relay. I'm not going to go too far into it, but that's how they use them. Lighting panel, lighting control panel. You bring the circuit to the relay, out of the relay, and go back to wherever it's supposed to go. Why? Because I need to be able to control them with relays. Low voltage contactors, they call them. That's a good application of it. This is just what counts and what's not count, guys, in terms of lighting fixtures. For example, the travelers would not count. So all this system right here will count as two conductors for, this is considered as three conductors for ampacity. Three conductors in terms of ampacity, not four, because one of them will be de-energized. Like in this case, this conductor, can you guys see that? That guy here, do you see it's disconnected? It's not carrying any current, right? So if you have a 3 and 4 way switches, I don't want to split here, but if you're an electrician, this is a big deal. Equipment, when you guys size, you have to pay attention to the voltage drop that goes around the equipment. So you come over here, you measure your voltage right here. No voltage drop. You come over here, you're going to find a voltage drop between your equipment. I believe this is for voltage drop. So, so a big deal when it comes to electrical equipment. A big deal when it comes to electrical equipment. This example is about the magnetic field canceling. I don't know if you guys can see the magnetic field canceling each other. Why we needed to cancel each other? Because if it doesn't, you're going to heat your equipment more. This is interesting, guys. This is how you size for equipment. Please, guys, it will help you really in the industrial project. If you have a motor, you guys remember how we, for motors, when we size the conductor 1.25 times full load current, overcurrent protection device was 1.75 all the way to 2.5 again times full load current. That's why we have a 30 amp fuse on a 20 amp conductor, because of that rule. Heater, continuous load. Heater for continuous load, guys, 1.25 times full load current, and this one is also 1.25 times full load current. That's the rule for the heater. Lights, we talked about lights, guys, continuous load 1.25, and the overcurrent protection device is also 1.25. Why the 1.25 magic number? Continuous load times, again, full load current. And that's how we size the conductors and the overcurrent protection device for different type of branch circuits. This happened to be a machine branch circuit, equipment branch circuit. This will be a lighting branch circuit. Excuse me. So at 30 amp, you can put conductor number 10 on it and feed multiple lights from it. 30 amp circuit breaker with a conductor. So this equipment has to be rated for 0.8 times 30. This has to be 0.8 times 30. All these amp wise, and this equipment has to be rated for typically 0.8 times 20, the conductor size. That's the size of the equipment that you can pull out of these branch circuits. Why 0.8? 0.8 is the opposite of 1.25. Take the load, multiply by 1.25, get your conductor. Take 0.8, multiply by the conductor, get you the load. So that's important outside equipment. We talked about this temperature, guys, rating and what's not. I took you to the installation. This is 250 kcm, XXHW. Look at that. In a dry location, guys, in a damp location, and in a wet location. Look how if you use at the same 250 kcm in a dry location, give you 255, damp 255, 255. If you put the 2 next to it, if you use it in a dry and damp, 290. If you use it in a wet location, it should be 290, all of them. It should be 290, all of them. I think we're missing something here. XHW. Okay, so these are the conductor ampacity, allowable ampacity. So certain conductor, guys, can change the ampacity. That doesn't sound right. The certain conductor change the ampacity with the location. XHW, I thought it doesn't. It did change it to XHW. Yeah, they just XHW actually should be in a wet location. Let me just tell you, I think this is a mistake. XHW, what is that conductor? 250? 250. XHW for derating purposes. 290 for derating purposes in a dry location. Okay, so this should be in a dry location for derating. This should be 292, 290, and this in a wet location becomes 255. See what I mean? It changes. XHW has 2 temperature rating, one wet, one dry. XHW-2 has 1 rating. It's all based on the 290, dry or wet location. We talked about this table, guys. It's been some time. Temperature derating, we talked about this. I talked about this, right? Right? Talk about these. Please. This is the ambient temperature and how you add. They call it application of correction factor in sunlight. Temperature, you add. Here's a very good example, guys. It's already given to you. Look at this one I have in Arizona, Phoenix, Arizona. Outdoor ambient temperature is this. You add another 30 because you put the conduit in the roof, give you this amount. Look what happened. If you're using this insulation, here's your derating. If you're using this one, here's your derating. Then you find the ampacity of your conductor and you chopped it down based on the insulation. Now this is how much these conductors can carry. Based on the insulation, the same size. One can carry 67.5, the other one can carry 49. I cannot emphasize enough that the insulation can make or break your life, basically. Any comments, guys? Any questions? Any comments? Any questions in terms of insulation? Look at this one. If you're using Illinois, look at that. Our ambient temperature in Illinois is 91 compared to, Chicago compared to Phoenix. You add another 30. The same conductor, guys. If you put it in Phoenix, it carries less current than if you put it in Chicago. Does that make sense to you? So if you're doing a project across the nation, pay attention to the ambient temperature. Look at the ambient temperature, same conductor. Now look at this. Now if the same conductor you put in Chicago is carrying 77.9, you put it in Phoenix, it's carrying 67.5. Because of the ambient temperature and the elevation. What's in it for you when you have a project in Arizona or any place where it's a hot climate in the south? Pay attention to the ambient temperature if your conductor are outdoor. Now what happens if you are a conductor are indoor? Who cares? Indoor conductors, typically the ambient temperature is controlled. Any comments, any questions, guys, about the sun effect and the derating factor on the conductors? So that's a good example of that one. Ambient temperature adjustment for the sun. That's exactly what we were looking at this one, guys. That's where you get your factor based on, I can't emphasize, the factor is based on how do you put the conduit. Do you put it right on the roof or do you put it 36 inches? So do you put the conduit here or you go all the way up to and you put it at 36 inches? If you put it here, you have to add 60 degrees Celsius. Okay, I'm sorry, Fahrenheit. If you put it right here, you're up to 25 degrees Fahrenheit. But if you guys have you guys been on a roof of a commercial building? Do you really want to go put your conduits 3 feet off the ground? See how ugly they look? They could. So that's my conductor. This is a few things, guys, about the rating of the equipment that you have to be. So, for example, 15 and 20 amp receptacle switches, COAL, copper or aluminum. So it tells you if you can put a copper or aluminum. I want to emphasize if it doesn't have anything, it's rated for copper. If it says none, rated for copper. Can you guys see that? Non-solid copper. So there's a lot of 30 amp and greater receptacle switches, non-copper. So you please pay attention to the rating. Most of the equipment I use, guys, are rated for copper, so we use them typically for copper, especially on the branch circuit. Wire connectors, it says on them, a lot of them says copper aluminum, so you can use them with both. Wire connectors, copper aluminum, and what's not. But that's when you get into when you become a project manager. Dirk, my friend, and you want to pay attention, order the material. That becomes a big deal. We talked about the continuous load and how you multiply the factor. This is how we size branch circuits and loads, guys. If my load, look at this, non-continuous load, here's my amps, multiplier is 100. Continuous load, here's my amps, multiplier of 100. And then to size the whole branch circuit, guys, so I have a branch circuit coming in here and feeding this load and feeding this load. What size branch circuit do I need? Right? Can you see that? You take that non-continuous load, add to it 125% plus the continuous load, and that will get you 90 amps. 90 amps. So the rating of this circuit here will be 90 amps. Can I get you guys to understand the way they size branch circuits and feeders and service? They take the continuous, add 25% of it. You guys did it with me for load count. The non-continuous, you add it at 100%. Branch circuit, feeders, or services alike. Okay, lighting. Lighting is always continuous. So when you take a continuous load, amp rating of overcome detection device, load 72. Okay, result is this one. So that's how we size a continuous load. You take your so I have my load is 75. Multiply my load by this, get you 90 amp. The size of the overcome detection device, as well as the conductor. Size of overcome detection device, as well as the conductor. We talked about 100 amp. Limitation of conductor obviously for table. This is an interesting because it summarized this one for you guys. For example, so 60 degree, the summary, the law here for the termination law, number 4 through number 1, you're defaulted to 60. For derating, you can any one of these for derating. If you have more larger than number 1 or larger than number 100, you default to 75, and you can derate. You're permitted to derate based on either 75 or 90, depending upon the installation rating of your conductors. So this will summarize which column do you use. 60 if you have 100 amp or less, unless you know otherwise. Unless you know otherwise, the installation. This is, I want to. This probably another. Please highlight this one. I can't emphasize, guys. It will help us as we go through and size our conductors. We looked at these before, and I told you to highlight this and this and this and this, basically. So this is summarized. How do you size a branch circuit? The common denominator between all of them, guys, is 1.25. Can you guys see 1.25, 1.25? Non-continuous based on the load. HVAC equipment, it's already named the name on it. Overcam protection device 1.25. HVAC equipment is already on the nameplate. No multiplication for non-continuous. Motors, there's a whole slew of things, 1.75 to 2.5. And the next standard, for a lot of them guys, the next standard you can use here, next standard. This one is maximum already assigned for it. And this one typically also the next standard. This is how you size the branch circuits and overcome protection device for different type of equipment. The common denominator between all of them is one word, 1.25. If anybody ever asks you how do you size and you have no idea what type of load, how do you size a branch circuit or a feeder? 1.25 for the conductor and 1.25 for the overcome protection device. And guess what, Derek? You are right 90% of the time. Did you guys hear me? 90% of the time you're right. The 10% is what? The details. So please remember that one, especially for engineers. I'm going to skip on that one. The last thing, guys, they have a nice table for you. I don't want to overwhelm you with that. This table has a lot of things. I don't think I ever seen any table put in more complicated and more interesting situation than this. I'm going to walk you guys very quick over this since I have my time. Look at this. The way this table works, and they're asking you to do a homework in the back, Karen, that you were supposed to use this table. Look at this. I have a luminaire. The luminaire is style 1. There's 27 of them. Okay? 20, how many? 27 of them. Multiply the 20, each one of them is 61 volt amp. So multiply these two by each other. 27 fixture, 61 of them. That will give you a total of 1647. Very easy. The number of the fixture, the volt amp of each fixture, the total volt amp. The second one, so this is up to this is your total. Straightforward, this is equal. Now, take this, ladies and gentlemen. The load type C stands for continuous and non-continuous. R receptacle. So there's continuous, non-continuous receptacle. Receptacle is also non-continuous. So you see C is continuous. Okay, when you size your conductor if it's continuous, what was the magic word that we said? 1.25. Ambient temperature, it looks like they're using it at the right ambient temperature, 86, so I don't have to do it. Correction factor for ambient, don't worry about it, it's 1. Okay, and then carrying conductor 2. So, Derek, if I have 2 conductors in the conduit, do I need to correct? No. If the ambient temperature is the same as the 86 or 30, do I have to worry about it? No. Then ambient correction factor is 1. No, don't worry about that one. Then the allowable ampacity, guys, is 17.2. That's taking the load, dividing it by the voltage. The conductor size is number 12. And the overcome protection device is number 12 for this circuit. So now for this, all these fixtures, there's 27 of them, guys. I can put them on a 20 amp circuit, number 12 conductor. 20 amp circuit, number 12 conductor. And that's circuit number 1. Any comments, any questions, what they did here, guys? Any comments, any questions? Let me take one more fixtures, how they did these. So that's basically what they did. Grouping them. If you go down, oops, I don't want to go that far. I'm just going to go to a heater or sign or what's not, right here. So that's for lights. If you go to another type of load, this type, let's say the air conditioning, air conditioning outdoor. The load, it's one of them. Here's the load for that one, multiplied by this. It's hermetic conditioning. The derating factor is 1. Ambient temperature looks like it's higher. So here's my derating factor based on ambient temperature. 3 conductors, no derating based on conductors. The ampacity is given this amount. And then the conductor that I need is number 8. And that conductor will be protected by 60 amp fuse or circuit breaker. Guys, this table takes 2 things into consideration. Actually, 3 things. Is the load continuous or motor or HVAC equipment or non-continuous? So you can multiply by 1.25 or not. Or the overcome protection device is going to be the nameplate, or how do you going to size the overcome protection device? That's number one. Number two, I have an ambient temperature condition, so I have to size based on ambient temperature, different ambient temperature. And the last one, guys, am I bundling them in one conductor, so I have to derate? This is probably involved. The table is very, very involved, guys, in terms of calculating two things. So I'm going to summarize it. When you size conductor, guys, you have to, number one, you have to pay attention is it continuous? Continuous. Size the conductor. Number two, derating. Derating. Am I derating based on temp and bundling? Bundling, if I spelled that right. And number three is voltage drop. So if it's continuous current, you came up with 1 watt. If the rating came up with 2 watt, if the voltage come up with 3 watt, which conductor, gentlemen, are you going to use? One more time. When you guys size branch circuit and feeders, there are 3 things you have to take into consideration. One of them, continuous load. Size your conductor. So I have a load, and I came up with 1 watt, continuous load. Then I have to derate. Because of derating, my temperature conductor derated came up with 2 watt. I have a voltage drop problem, so my conductor came up with 1 watt, 3 watt. Then at the end, you are to use the largest conductor. Can you please keep this in your mind, guys, as you size your conductor? Let me tell you now, this is the detail. Let me tell you, simplifying it. Simplify this. 90% of the time, gentlemen, where are you going to be? Right here. Derek, where are you going to be 90% of the time? Size based on continuous load.
What do you mean by overcurrent selection amps?
Overcurrent selection amps, that's the largest overcurrent protection device that you're supposed to select for this, based on like 1.25 times the full load current, or 1.73, or 2.5.
So that's higher than the actual amp, the actual overcurrent amp rating.
You're looking at, I'm kind of coming to it in a second here. Any question, guys, about this though, before continuous derating and voltage drop? Continuous derating and voltage drop. That's how you're going to be it. Let me go to the, keep this in mind. So please, I can't emphasize spending some good time on this chapter, guys. That will help you. So now coming to the way they did it here. Okay, so like I said, here's the quantity first, then the load, each volt amp, that's easy. Then you go into calculating the correcting, calculate or connected. So you multiply this for light, this number by this number, get you this number. Load factor, if it's continuous, it's C. Non-continuous, so what's not. Load factor modifier is 1.25, right? If it's continuous, you have to multiply by 1.25. Ambient temperature, unless it's 86/30, you have to derate. So, for example, all the way down here, all of them are here. Look at this. It looks 138. So what do I have? Look at the number here change. My derating temperature is 0.88. Do you see that? So I have to have, all of them are 86/30, no derating. What's one, by the way, one, you don't derate. Anything other than one, you derate. So see how the only time it changes right here, because the ambient temperature seems to be higher. Okay, this is my ambient temperature. Then you have the correction factor. Then it tells you how many conductors in the conduit. Look at them. 2, 2, 2, 2, 2, no problem. 2, 3. All of them are 3 or 2. Do you see the number right next to it, guys, is 1? If you have 3 or less, do you have to derate based on bundling? No. Yeah, see it? So there is no derating based on bundling. Why? Because the conductors are either 3 or 2. They're not more than 4, more than 3. Okay, so the ambient temperatures, all of them are 1. Then minimum allowable ampacity, this number here, Derek, the 17.2, if you take the 1647 divided by 120, multiply it by 1.25, that will get you, I believe that will get you 17.2. Can you guys try it? Take 1647, divide it by 120, because that's a voltage, and multiply it by 1.25. Right? Okay, so this is basically this number, divided divide this number by 120, multiply it by 1.25, right? And that will get you this number.
Well, okay, so you're saying for theirs, they want to know like calculated load in amps?
Yes.
That should just be like the number of their, like, radians or whatever.
Yeah,
like,
here.
times the amount, times the amps reformed.
Or, you're right, the amps or the volt amps. Here, instead of using amps, they're using volt amps. You're absolutely right.
But they want us to calculate amps and VA.
Yes, but in this order though. VA, then amps. You're right. So here's the volt amp. My volt amp is here, right? The total. Here's my volt amp. Then here they switched it into what? Ampacity, amps. By dividing the voltage by what? 120. The volt amp by
No,
120.
they got that, but they also wanted calculated loaded amps.
So you can use the largest.
Did
In
you say 150 for it then?
150.
Like, that's
Ah, I see what you mean. You for commercial building, either you go by the connected load or the code load. What's the code load? 3.5 for lights, or the connected load, just the volt amp of all these fixtures, whichever is largest in terms of sizing your branch circuit. But typically, that's for feeders, guys. Keep it simple. For this calculation, what you need to do is find the volt amp of your fixture to find the branch circuits. For feeders, we use the largest of all of them connected together, or the volt amp from the NEC code book, whichever is larger to size the feeder. That's what you guys did with me.
Yeah, but I mean, like, for theirs, they're saying that you've got 10 linears that are 120 volts, they're 150 amps. So your calculated load with VA should be 1500 VA. Because you take the amount of times the ampacity, or you just do amps times VA.
Always work VAs. Take the amp of the fixture, multiply by the voltage, get you VAs.
Yeah, and then your calculated amps that.
Then you divide,
Minimum.
then you add them up, then you divide them by the voltage. That will get you the amps for the circuit.
So just 10 times 150 divided by.
10 is what's 10 again? Give me
That's
what?
the number of amps.
Yep, 10 times what's the 150 is the, you got 50, 150 is the
50 amps.
amps, not volt amps. Look at it again.
That's what it said for it. It says 10 volt fluorescent luminaires rated at 450 volt amps each.
Volt amps. So you might, now you, okay. When you said the amps, it blew my, okay. Volt amps, not a big deal. And then from here, gentlemen, you size your conductor, right, based on this, and you size your overcome protection device based on this. And this is just telling you that this conductor is rated for 20 amps non-continuous. Any comments, any questions, guys? Any comments, any questions? Karen, any comments, any questions? Please, this is a very good chapter, guys, that walk you through how to size based on the rating and temperature. Please do the questions at the end of the chapter. I don't want to start other things today, so what I would like you guys to do is, if you're done, how are we doing with riser? If you're done with your riser in Revit, please log into your Revit and start laying out your receptacles. Start laying out your receptacles. I don't want to overwhelm you to showing you how to do receptacles, guys. Easy. Grab a receptacle and put them where they should be. Where should they be? Please look at the narrative that we have. You guys are engineers. You have a narrative, you follow it, right? You have a narrative. I gave you a narrative, you follow it. Go to where the receptacle section, and it will tell you where to lay out the receptacles. Grab the receptacles. It tells you either the duplex or quad. If you can't find the quad mat, I will show you how to load the quad and start throwing your quad and receptacle into the building. Cool? If you're done with your riser.
Do you want the riser big sheet or
11 by 17. Risers will be done by Friday, printed 11 by 17 with the schedule done. That's kind of the expectation. So that's all I have. Thank you, guys. Close that one.